Yes, let's do this problem right here. This first question is, we have two questions. The first question is asking, let S is equal to x1, x2 in R2 space, and they say 2x1 is equal to x2. Is S a subspace of R2? Justify your answer. So first of all, we have to know that to be in subspace of R2, it has to satisfy three conditions. The first one is it has to have zero element, and second one is it should be closed under addition, closed under addition, and the third one is it should be closed under scalar multiplication, closed under scalar multiplication. So let's see whether it satisfies these three conditions. So first of all, what is closed zero element? Zero element is basically when you substitute 0 for these values, x1 and x2, you should get 0 all the way. So in this case, if you substitute 0, that's going to be 0 anyway. So it has 0 element, 0 0. So this satisfies the first condition, and so the second one is closed under addition. To prove that, what we have to do is we have to pick two numbers. Like for example, if I pick a, b, let's say this belongs to S. Also, let's pick up this one, x1, x2 belongs to S. So according to the equation they are given, so this means this basically what does this mean is the multiplication of the first number twice. So two times multiplication of this first number should be equal to the second number. So if this is the equation for this one, so this belongs to this. Therefore, this should be 2 times of A should be equal to B. And here's the same thing. 2 times x1 should be equal to x2. So that's the condition they have given. So let's rearrange this one and make it 0 to make this one much easier. 2a minus b is equal to 0. 2x1 minus x2 is equal to 0. So now to prove that it's closed under addition, what I have to do is I have to add this both together and see whether it is true when we add them. Is this equation true? So let's add them together. So we have a, b, and x1, x2. So if I add both of them together, I will get a plus x1 and b plus x2. So according to this equation, it should be true to the addition of this one. So there's 2 times multiplication of the first values. This 2 times multiplication of this first value, a plus x1, should be equal to the second one, which is b plus x2. So let's see whether it is true. So in this case, if I can rearrange this one, 2a plus x1 minus b plus x2 is equal to 0, and also I can multiply this one, 2a plus 2x1 minus b minus x2 is equal to 0. So if you see, I can rearrange this one into different forms. So 2a minus b, and here I can add plus 2x minus x2 equal to 0. And also, like so we know that so from this one I can substitute this value here, 0 0. So if I substitute this one, it's going to be 0 plus 0 is equal to 0. So this satisfies the condition, because so when you rearrange, this is giving 0, this is giving 0, this is also giving 0. Therefore this closed-ended addition. And to prove closed-ended scalar multiplication is say it's a little bit different. For example, let's pick x1 and x2. This belongs to S, and also we pick a scalar value. Let's say is k, belongs to the R. So if this is true, what we have to do is, first of all, we know this equation is true. This 2 times multiplication of the first value is equal to the second value, x2. So I can rearrange this one and say it's 2x1 is minus x2 is equal to 0. So let's see if I do this for the multiplication of this one, is it still true? Let's check that one. If I multiply this one by k, x1 and x2, I will get kx1 and kx2, kx1 and kx2. So in this case, what do I have to do? What has to happen is the first multiplication of first value should be equal to 2 times multiplication of first value should be equal to the second value. So therefore 2 times multiplication of kx1 should be equal to kx2, and if I bring to the other side, this should be equal to 0. Kx2 this should be equal to 0, but we have to make sure whether it is true, whether it's 0. So to do that one, what I can do is I can rearrange this one. I can take the k common right here. If I take the k common, is 2x1 minus x2 is equal to 0. So we found out that according to the equation, we know that 2x1 minus x2 is 0. So I can substitute here. K times 0 is equal to 0. Therefore we know that 0 is equal to 0. Therefore it's true. It's true for scalar multiplication. Like if I rearrange this one, it still gives 0. So that means this is closed under scalar multiplication. So this is how we prove this system. Therefore we can finally state that this is the subspace of R2. Therefore we can say S is the subspace of R2. So that's how we finally state this one. And let's do the second question. The second question is much easier because it's going to be only one step, because it's very obvious here. If you substitute x2 0 for x2, it's not going to be equal to 0 because it's going to be equal to 1. Let's see. So I'm taking the b and let's substitute. I'm checking the first thing, whether it has 0 element. So if I substitute 0 for the x2, x0 is equal to 1. This doesn't give us 0 0. We want 0 0. Like for example, for the first one we substitute 0 0, we got 0 0. But for this one I can't substitute 0 for the numerical value. So that means this doesn't have 0 element. Therefore this fails the first condition. Therefore we don't have to do the other conditions. We don't have to check the others. If it fails one of this condition, it means it doesn't belong to the subspace of R2. So we can say this is not a S is not a subspace of R2. And this is how we prove these kind of questions. I hope you guys understood this concept. See you next time.